Hello Tanya Jain, welcome to Philo.
Good afternoon, sir.
Good afternoon. What's your doubt?
All the questions are my doubts, right? So you can tell me in series.
Okay, let's start with question number first. This is first. Okay. A ball of mass 5 kg moving with speed 8 meter per second collides head-on with another stationary ball of mass 15 kg. If the collision is perfectly inelastic, then loss in kinetic energy. So we have to find out loss in kinetic energy, and collision is perfectly inelastic. That means after collision, both mass will stick together and move with same speed.
Yes.
So we have 5 kg that is moving with 8 meter per second and collides with a stationary object that is 15 kg, and that is it at rest. This is just before collision. Before collision. This situation is just before collision. Okay. And after collision, 5 kg and 15 kg will stick together and move with a common velocity. Let's suppose that velocity is v, and this situation is after collision. Okay,
Yes.
so we can conserve a momentum. Okay, so it says that initial total momentum is equal to final total momentum. So initial momentum has only 5 kg block, yeah, ball. So this is 5 into 8. 15 kg block is at rest, so it has no any momentum. Okay, so 5 into 8 is equal to final momentum will be total mass of the system will be 5 plus 15 after collision. And let's suppose its velocity is v, then momentum, final momentum will be 5 plus 15 into v.
Yes.
So it will be 40 is equal to
Correct.
20 v. So final velocity will be
Two.
2 meter per second. Okay.
Yes.
Okay. So final kinetic energy of the system will be half 5 plus 15 is the mass of the system into v square, that is 2 square. So final kinetic energy will be 40 joule. Okay. Okay.
Yes, sir.
Okay. Hello.
Yes, sir.
And initial kinetic energy will be half 5 5 kg mass has only velocity, so it will have a initial kinetic energy only, and 8 is square, so that will be 40 joule.
160 आ रहा है.
Sorry. Yes. तो कितना हो जाएगा ये 160 हो रहा है.
हाँ.
So loss in kinetic energy will be change in
120.
kinetic energy. So loss will be 120 joule. So this will be the answer for first. Okay.
Wait, sir. Let me check. Yeah, it's correct.
Okay. Now we start with question number 2. In question number 2, saying that two identical balls, each moving with speed v at right angle to each other, collide
Sir,
perfectly inelastically. Hello?
sir,
Yes.
sir, can you wait for a minute? I want to solve it by like myself also first.
Okay.
Just a minute.
Okay, I am waiting.
Okay, so you can start.
Okay, the next question is two identical balls, each moving with speed v at right angle to each other, collide perfectly inelastically. Their speed after collision is the collision is inelastic perfectly and moving with speed v at right angle. So the situation will be like this before collision. Uh, one has velocity v and mass m, another has velocity suppose v and mass m. Both are moving perpendicular to each other. Okay. So let's suppose this is y axis and this is x axis. Okay. And after collision, After collision, they will stick together and moves with a common velocity, and that mass will be 2m. And let's suppose it has velocity in x direction is vf and velocity in y direction is vy. Okay, let's suppose. Okay.
Okay.
Okay. So so uh, initial momentum conservation in x direction, okay. In x direction, momentum conservation, we will apply momentum conservation in x direction. So in x direction, m into v is equal to 2m into vx. So vx will be v by 2. In y direction, we can say that m into v is equal to 2m into vy, and vy is equal to v by 2. Okay. So actually, what they ask, their speed after collision. They want speed. Okay. So this is vx and this is vy. Final x direction velocity and final y direction velocity. So v vector is equal to vx I cap plus vy j cap. So v vector is equal to, that will be the v vector. Okay. So it will be v by 2 I cap plus v by 2 j cap. So magnitude of velocity will be speed final, and it will be v by 2 ka whole square plus v by 2 whole square. So it will be v by 2 into root 2. Okay. Or we can say that it will be v by root 2. So this will be the answer.
Yes, sir, it's correct.
Okay.
Yes, sir, it's correct.
Okay. So this will be the answer. And we have a third question. In third question, it is saying that a body of mass m moving with constant velocity collides head-on with another stationary body of mass m if the coefficient of restitution between the bodies is 1 by 2. 1 by 2 is the coefficient of restitution. The ratio of velocity of two bodies after the collision. Okay. One one object is at rest, same mass. Okay, and one is moving with constant velocity. Okay. So the situation will be like this. For third, one has mass m and it's moving with velocity v, and another mass m is at rest v4. Okay. And after, suppose m and m mass, this has velocity v1 and this has velocity v2 after collision. Okay. Okay, we can assume that. And coefficient of
Yes.
restitution is half. So we can conserve first momentum conservation. Momentum conservation we will apply. So we
I
can say
have the
that,
numbers. Can you solve it faster?
okay, m into v is equal to m v1 plus m v2. Okay. So v is equal to v1 plus v2. Okay, this will be the first equation. And second
Yes.
equation will be E is equal to velocity of separation. Velocity of separation, that will be v2 minus v1 upon v minus 0. That will be half. So v2 minus v1 is equal to v by 2. This is the second equation. Okay. So this will be the second equation. Up we have to solve this equation. Okay. So we can say that we can add this equation. So v2 minus v1 is equal to v by 2, and v2 plus v1 is equal to v, and we will subtract it. That will be v2 is equal to 3v by 2. So v2 is equal to 3v by 4. And we will put in the any equation, like first, in first equation. So v1 is equal to v1 will be v minus 3v by 4. That will be v minus 3v by 4. So it will be v1. So v1 is equal to v by 4. So v1 is equal to v by 4. So ratio will be we have to find out v2 upon v1 or v1 upon v2. Just wait.
V1 upon V2.
v1 upon v2. Okay. So V1 upon V2 is equal to V by 4 upon 3V by 4. So it will be cancelled out and it will be 1 by 3. This will be the answer. So 1 by 3.
Thank you, sir.
Okay, welcome. Please give a feedback.
Sure, sir.
Okay.
Sir,
Yes.
uh, you are available all the time. Like I can connect with you. Like there's this particular time, or I can connect anytime.